Criteria for proper compaction. Just tell me, it may be wrong. Just think and tell me, because you have to think more. Critical thinking. Online teaching, I have to impart more of critical thinking than just seeing and understanding.
Improper compaction.
Yeah, achieving proper compaction. Three things are there. Can you tell me at least one? It's compaction. How do you can say how you do and how you plan for a compaction, then you know what is required. You should have knowledge on the properties, right? Physical properties, chemical properties, especially bulk density of soils are important for a successful or complete 100% compaction of the soil that have been used for earthwork operations, right? What is bulk density? What is bulk density? Can you see the slide? Review on last class. Can you see the slide? I'm now showing the winners last class. Can you see the slide?
Yes, miss.
Please tell me, what is bulk density? What is density? Quick one. Others, I hear the same voice all the time. How many of you joined so far? I will take it later. Can you tell me what is bulk density? What is density? Mass over volume, right? How much material is stored or occupying a given volume. Bulk density refers to the same density but for loose materials. What do you mean by loose material? Anybody? Please think and answer me. It can be wrong, no problem. I'm not testing now. But a response is important. All of you should answer, otherwise I pick people to answer. Make it interactive. What do you mean by bulk density? I asked. Now I'm asking why. No, I say it's a loose material, right? Bulk density is referring to the loose material like grains, like soil, right? Earth, wherein you cannot use density because it is not tightly packed. Loosely packed, for any loose material we use bulk density. Okay, what do you mean by loosely packed? Why do you say this is loosely packed? What are the other material you can see there? So in addition to soil, you can see the air spaces, right? The pores are there, large number of pores are there. The pores might be occupied by water, air, or any glass materials. If it is sandy soil, more glass particles or carbon. Many other minerals are together with this, isn't it? Okay, let's move on. Preview the last class, we had successful winners, but I'm sorry I cannot name them. I really have to quit this type of unknown people. Mahadir, Tun Mahadir, Mr. Mahadir, all those things. Now the winner is Xia Yun Yang. And I also have 5 people in our list. Mahadir, or forget about those 2 guys. Please give the true name. It is being marked. Otherwise, I cannot give mark. All right. Xia Yun Yang, Mayat Mao, Yizu, Derek are the winners of last class. Keep moving on. Keep up the good results. Everyone should go to the higher level. Understanding of the topics and remembering is important because more of theory, right? Okay, today's class. Today we have factors affecting the, okay, today's topic is on foundation, right? All related to types of foundation will be taught today. Number 1, factors affecting choice of foundation, type of shallow foundation. I use the short form SF. All the types of shallow foundation will be taught today. Advantages and disadvantages of shallow foundations and possible failures and solutions of shallow foundations, their limitations. By that you can learn what are their limitations in adapting the shallow foundations. Can you all see the slide?
Yes.
Yes.
Yes, miss.
Okay, good. You see here, proper foundation design is important to avoid all these problems, right? Number 1, the big building, residential building is about to slide, about to fail, and this one already failed, having deep rooted, right? The total foundation itself gone out. And here again you can see another accident caused by improper consideration, improper design of foundation. It's all mainly due to the foundation failure. We can say we already proved. There are some newspaper cuttings you can refer later. All are due to foundation failures, foundation design failures. And the last one here, you can see here, roadway, road breaching, right? It's not, the drainage is not properly flowing the water or disposing the water. There is a blockage, and these are all caused due to improper basement, improper laying of foundation. Let us understand how this can be alleviated by proper understanding of the type of foundation, their limitations, and their conditions under which it can be constructed. Number one, before you go into actual foundation design, you have to know the total structure or where the location of the foundation is. Where is the foundation? Bottommost, right? Bottommost, the prime structure in any building. It can be residential, it can be research building, it can be of any type of building, right? You can see here a building can be, a construction can be classified into 3 categories. Number one, the bottommost will be foundation from here to here, and then the substructure, this is called as basement. Sometimes some structure may not have basement, like shallow foundation. Most often they may not use the basement because this is being occupied by the shallow foundation. We will see how they are. And then above this basement is what is called superstructure. The top structure of the building will be constructed. Okay, as engineers, we should know how to design the foundation, right? The first and foremost thing for a design is calculation of the load, consideration of the load, right? What's the purpose of foundation? Foundation is transferring the whole load, the entire load of the substructure and superstructure into the ground. Hence, the structure is safe, structure is stable at any point of time, right? It may be a heavy wind, it may be earthquake, it may be a flood, right? In all situations, vulnerable situations, the building is safe and strong due to proper consideration during foundation design. The first thing that you have to decide or calculate is the loads, right? Let's understand what are the types of loads which has to be considered for a foundation or footing design. Come on. Dead load, live load, wind load, horizontal pressure, structural member forces, oblique force, and earthquake, right? These are the major forces that has to be decided. Depending on the structure, whether it's a residential, medium story building, or a multi-story building, any skyscrapers, or any type of bungalow, right? Bungalow type building. Depending on the occupancy, the types of load will be varying. You don't have to calculate entire thing for all the structures because otherwise you'll be over designing, right? There are limitations. You will understand by practice. Okay. Start with, but these two are major and main loads that has to be considered in any footing. And then this is also important for more than 3 floors, more than 4 floors, 3 to 4 admitted. Above that, you should consider wind load. You should really go for an analysis for wind load, and then for the pressure and all other things. Let's see one by one what are they. Okay, let us understand about load distribution. Okay, I think the explanation is not here. The slides are removed because I need to accommodate more of types of foundation. Right, let me explain what are the load types of loads. Dead load. Dead load means self weight of the building. Self weight of the building or weight of the building, right? It depends on the material used. It depends on the how much is the size. Depends on the size. Depends on the size, length, width, depth. Based on that, you can calculate how much cubic meter of material is used. That is called dead load. Okay, this is self weight of the material. Live load, it may be the load that is moving. That is, supposed to be like if it is a building, a residential building, all the movable loads like your furnitures, your decorations, your landscaping, all this will be considered as moving loads, or all the moving loads. All live loads means mainly moving loads, or the loads that is apart from the material that is used for construction, and the elements of the building like columns, beams, slab, and so on. Right, all the moving loads. Wind loads. Wind load, you know, right? Due to wind. There are different types of analysis and design. You need to know which direction, and there are codes available. You can borrow the building codes. They have their all the code values for their coefficients for multiplying, finding out the safe bearing capacity, find out the proper design and sizing of the materials, sizing of the components. Okay, you can follow the building codes. Horizontal pressure. This is actually due to the when you go down, you will realize there are some layers, right? There are some static pressure which is being thrust, right? The thrust under which the building is standing. So you should understand what are the types of underground thrust that is applied, or by the neighborhood. It may be superstructure or under the ground. Mainly it is affected by the underground. What are the neighborhood pressures that is coming over the building? Structural member forces, right? Member forces, yeah, it may be a beam member forces like beam force on the beam, force on the column, forces on the slabs, and so on. Oblique force we need to calculate separately because sometimes it is typical for certain buildings. We will explain to you later. Uplift forces, right? There are chances of uplift, right? Due to movement of the earth, due to movement of the water under the ground, there are chances of uplift. So you should know how much is the, especially it is affected by the foundation. You need to calculate what is the uplift force. And earthquake, you know, due to again, it may be a combination of this horizontal pressure and uplift together with, if this is very high, the landsliding effects or earthquake effects will be, in simple words, start with a settlement, end up with a landslide. The total building itself collapse. Load distribution. Let us understand how the load is being distributed. There are two types we can see. One is for the slab, one is for the another one for the roof. Let's see how a roof load is being distributed and transferred to the down to the foundation. Started with roof. Here is the roof truss. I'm showing a truss building, but still valid for any type of concrete or brickwork. Right, this is the roof. See the direction of loading. The force or the load due to, what is the unit for load? Unit for load, please. Load or force? Newtons. Okay, let's take it as a newtons or kilogram force if it is metric. So this force is coming over from the roof. It is being transferred to the beams, right? It is being transferred to the beams, right? And then it is being transferred to the columns, right? Columns. You are seeing the cross-sectional elevation of the building, maybe a side view, right? This is being transferred to the column next. From the column to the subsurface or the basement, finally to the foundation. Can be of any type of foundation. You can see the transfer of loading by the arrow, direction of the arrow. You can see how the load is transferred to the foundation or the footings. This is for the roof. And for slab, you can see the slab, how the load is distributed to the from the slab or the roof. Okay, roof slab. Okay, I can call this, sorry, slab. Okay, here you can see the slab. Well, let us take at one level. There's a nice drawing to explain to you. The slab loading is, slab is resting on the beam, right? Slab is resting on the beam. Hence, the loading due to the slab is transferred to the beam, right? There's one thing. And you see the cut section here clearly. And this beam will take the column, right? The load from the beam will be taken by the column, right? Taken by the columns. And then the column will transfer the load to the foundation, or this is having a footing, a pad like, or a cap. We can say it can be a pile cap, it can be a what is that? Footing cap or a pad. Okay, being transferred to the foundation below the ground. Any questions so far?
No, miss.
Okay, types of foundation. There are two. Okay, basically the foundations are classified into two categories. Wherever you go, you work in Europe, you work in Australia, work in Middle East, India, China, anywhere, the types of foundations are shallow and deep. You need to understand, right? Where the shallow foundations are used, low cost, light load, where the bearing capacity is good, right? Subsurface soil is good, depth of foundation is less. There are many criteria, we will see one by one. Further, it is classified into individual footing, combined wall footings, combined footing, mat foundation. This is the overall broad classification of the foundation. But please do not follow this classification. We have a separate classification into 5. You can follow that one for types of foundation. This is captured from the text. Deep foundation, I will explain to you later in the next class on deep foundations. Let's do the classification only here. It is just against the opposite of shallow foundation. High cost, where the bearing capacity is low, where the groundwater table is immediate, where there is a problem of settlement, where there is a heavy load coming in, superstructure is higher like skyscrapers, poor soil or bearing capacity is low, you can adopt deep foundation. Classifications are caisson, drill piers and piles are used mostly. Deep foundation we can classify into 3. Number 1 is pier or pile and friction pile. 3 types only. Here you can see, I don't know, just keep it like that. But there are 3 types, major types: piers, piles, and friction piles. Why do we need foundation? A great question. Come on. Before I go, let me understand your knowledge. Why do we need foundation? Answer me. Why do we need foundation?
To withstand the load.
Okay. To transfer the load, right? Number
to transfer the load from the building to the earth, to the
superstructure to the ground. Withstand any type of unknown loads or moving loads like wind, live loads, right? Unexpected loads coming over the building. Good. Why do we need foundation? A foundation is provided for the following purpose. Come on, detailed information is here. To distribute the total load coming on the structure, distribute, transfer, distribute, all are same, to the larger area, mainly the earth. To support the structure, to give enough stability. I don't go in detail about giving more examples today because I heard there are some tests after this. Anyway, I will post this later if there are many examples needed through videos. For now, I touch upon the important things. Okay. To support the structure, to give enough stability to the structure against various disturbance like wind, earthquake, landslides, right, and so on. Forces such as wind, it's already here, rain, heavy rain. To prepare a level surface for concreting and masonry work. Foundation is required to prepare a surface, level surface, a pad or a mat for the masonry work above. Okay, on which it's a pad or a base for holding the walls and columns above. Okay, I don't do much on this, or you can understand. Primary factors. Let's understand the primary factors that affects foundation. Okay, subsurface soil or undisturbed soil or engineered field. Okay, the fact. Okay, before I go into this listing, can you tell me what are the factors? You know what is foundation design, right? Now tell me what are the factors will be affecting. This is one type or many different type. What are the factors affecting the foundation design?
Soil bearing capacity.
Bearing capacity, very good. So that decides the type of foundation. You should be clever, ingeniously select the type of foundation when you start the planning itself, right? In the planning, designing, before you do the construction, you should choose the proper type of foundation to avoid any type of failure. The example I shared last class in Gompak, right? In Gompak, there is a landslide because of unidentified underground water below the earth. Okay, after some period of service, they got the problem, right? Come on, let me check how many joined. People, 112, very good strength today. Only 2 missing. I don't know who are they. Okay, come on. Where are we? Why do we need can you all see the slide? Why do we need foundation? Oh, I did already.
We didn't run factors.
Huh? Yeah, can you see the slide?
I was just saying, yes.
Okay. Anytime you cannot see the slide, please stop me. Okay, thank you. Subsurface soil. Okay, the conditions are the criteria which will determine the type of foundation will be subsurface soil. Whether your subsurface soil is just 1 meter below, right? And this subsurface soil is very hard, or soft or need to be processed, compacted more. And then groundwater conditions, whether the groundwater trouble is at one, see in Malaysia it's quite common, unlike Saudi, India, Midland, China, we are all suffering, these three people in China, I personally had problem. India, China, and then Saudi, they all have water very deep, right? No water or very deeper, like they have to go about 200, 300 meters below the ground, right? When you come to Malaysia, maximum 20. If you see the borehole data for Malaysia, you can see about 10 to 20. I am saying higher, even 5 meter deep to 20 meter, maximum 20 meter deep, you can get very good groundwater. So you need to check where the groundwater level is, whether it is a continuous supply or intermittent supply, what is the type of source, then you decide the type of foundation. That is important. You should not be putting your footing on the water table, right? Reach the water table, right? It will be washed away. Your structure will be washed away. And structural requirements. What are the structural requirements? Whether you need, sometimes they want a floating structure inside. Sometimes they want a stable structure, some landscaping, right? Full of landscaping, or full of moving material like theme park, right? Theme park construction, and so on. So it depends on that structural requirement as well. Then bearing capacity, that's the most important thing. Our friend also told, bearing capacity is the main thing that will decide the type of foundation. When bearing capacity is good, already good from the soil, you go for shallow. If not good, go for deep foundation. Okay. Groundwater control. Okay. Some problems we are discussing here. This is in general. I didn't go into shallow foundation yet. Some problems. Care must be taken when excavating soil, as it is possible to reach the water table level. The moment you get water, we are digging the ground. When the moment you see the water, you reach the water table already, right? But you see whether it's a continuous supply or intermittent supply. Intermittent means small, some duration of time it will be there and no water later on. So find out. And how do you overcome this problem? By using proper pumping arrangement. If there is any type of oozing out or passage of water, intrusion of water into your underground digging, then you should see what is the first thing you avoid, right? Wherever there is a low water table level, avoid such location and see whether you can entrap the water or you can remove the water, pump out the water by using this type of suction pump to pump out the water so that it will not affect your construction. That's the information here. Why you need to remove water? These are the things. Okay, first of all, why you get the water? Because of hydrostatic pressure, hydrostatic nature of the water table there. What is hydrostatic nature? Some of fluid mechanics. What is hydrostatic nature? Anybody? Engineers? Problems of excavation. Depends on tendency to fill in excavation due to hydrostatic pressure. What is that? Hydrostatic. Some fluid mechanics. You have studied in fluid mechanics. Quick one.
Pressure that exerted by fluid.
Oh, pressure. Yeah, very good. Pressure caused by
fluid.
The water moves from the low pressure point to high pressure point.
No, you touch upon the point, but it is not the correct valid reason. You see, hydrostatic pressure. What's the statement? P is proportion to height of water, isn't it? That's the hydrostatic pressure. Pressure is proportion to height. As the depth of water, a column of water above that point is very high, there is a chance of more pressure, more thrust at that point, isn't it? As the column of water is reducing, the thrust will be very less. Am I correct? In one word, pressure is proportion to the column of water above that point, right? Say, for example, you reach 1 meter and you have a water column above. I reach groundwater table, the water column is about another 1 foot or more. It depends on how high it is and how deeper you're going in, right? The higher the depth of water, higher the pressure. So due to the high column of water, there is a chance of water and the soil moving into your excavations, moving into your construction site. So to avoid this excessive flooding of water, or it can be slurry because it mixed with the water and soil, it will come out as a flooding during the wet period. It causes increase in moisture, increase in humidity of the structure that you're going to build below the ground. So you should avoid such interruption of water by proper pumping out, understanding the column of water, understanding the hydrostatic nature of the water. Remove them. There are resistivity meter. There are meters and detectors and instruments, high-tech instruments available to quantify how much Q, what's ahead at that point. They are all used by Department of Ground. I mean, in Malaysia, it's Department of Works. Again, Department of Works, groundwater department. You can follow groundwater department to collect our borehole data. By collecting borehole data at that point, you know how much depth the water table is, how much the Q that can be obtained at that point. Based on that, you should avoid such points and decide whether just removing water can overcome this problem, or you need to change the point of foundation or level of foundation. Okay, so the problems are humidity, increasing excessive flooding, and spoil the structure itself. Construction waterlogged trenches is difficult, and construction also difficult, right? During construction, is if there is a intrusion of water, intrusion of change in moisture content, the concrete, if it is concreting, foundation is by concreting, concrete never get dried. All these problems are there. So hence you have to use remove the ingress of water by possible pumping. All right, this is what happening here. Use the possible pumping to remove the water that is, sorry, here this is the connection. So they remove the water, excessive water that is caused at the ground. Second, main factors, just now we saw the main factor, primary factors like subsurface soil condition, groundwater condition, structural requirements, bearing capacity, and there are secondary conditions that, I mean, factors, variables which affects your foundation choice. Construction access, methods, and site conditions. Okay, site conditions is playing major role in finding the foundation choice, whether your what do you call, public line or municipal line is nearby, whether the municipal line is far away. Depending on that also, it may decide how much, what is the type of foundation. Environmental factors, right? Whether it is it was a pond before. Sometimes they fill up the pond and start the construction, right? Environmental factors like land use pattern, and then the type of the climatic conditions of the place. If it is always humid, it is always cold region, you should decide whether the raft or the shallow type of foundation holds good or not, and what depth, how much time it is under humid condition, how much time it is under dry condition, you need to check. Building codes and regulations, you should also follow. Your design is depending, your design is limited or checked by building codes, so check based on the codes. This is also limiting your design. You cannot design, I mean, there you can, in the beginning, so I told you, at the site you may see civil engineer, you may see mechanical engineer, you may see a supervisor, but he is not an engineer at all, right? A project manager who has experience in doing design and construction, right? So these peoples may be misleading the structure, misleading the construction. At that point, you have to check for the building codes, right? These building codes and regulations will be helpful to design have a proper design, not misled by wrong designing, wrong regulations of the site. Impact on surrounding structures, right? Yeah, it's very important. Its impact, the impact is during construction and also after construction. During construction, you're using heavy machines, right? Right, drilling pile. Do you have an idea about how much is the pile capacity? Any idea? Just tell me random one. You know or you don't know, doesn't matter. Just give me guess what may be a pile capacity for a 15-story building. Say 15-story building. Pile means must be for a high skyscraper, right? Mostly. Can you tell me what is an example pile capacity? Guess? Any guess?
30 meter.
No, I'm asking the capacity of the pile, right? The capacity can be, okay, unit for this one is a force, right? It is taking the force. It is taking the load. Pile is taking the load, right? Transferring the load to the foundation. So the load can be in newtons. You can give me in kilonewtons, right? It's a huge load. So better we call this by kilonewtons. A pile capacity, a rough value for 15-story building, roughly, just rough value. May not be a proper design. We're not designing. A pile foundation. What may be this? Fantastic. You're nearing. So 800 kilonewton. The unit should be kilonewton. 400, 800, up to 3000 kilonewtons pile capacity. So you need to drill this pile into the ground without bending, without causing any damage to the pile or pile cap, isn't it? So it's an enormous force, and it may affect the neighbors by producing a huge volume, supersonic sound, right? So you should understand the impact. Mainly you should avoid, like you were seeing in Cheras, you can see Maxim. Always there is a complaint from Maxim condo. There are noise due to constructions going on around. Always very noisy, and people or dwellers are affected by. But it should be avoided by properly constructing. By avoiding noise, by having proper noise reduction equipments. That is the only way we can do it. But still, some of them cannot be controlled, right? So you should see how much the impact surrounding due to the structure during and after construction. Like we call this as a EIA. This can also be assessed by environment impact assessment pre and post. They are normally do environmental engineers of the building. They will do. You need to get approval from the environmental board for the impact, right, caused by. Especially when you construct a water retaining structures like dam, canal, you need to do EIA, environmental impact assessment, pre and post. Before construction, what was the effect? After construction, how this is going to be positive, or what are the negative effects due to construction of that particular structure. Like construction schedule. Okay, other factors are scheduling. It should not be prolonged very like nowadays we can see 5 months work, they can finish in 24 hours. I don't know how the structure is and how the strength is. Only the people who are using it must tell. But it's today, as on today, a 5-month work can be completed in a week, or we are recently the COVID, during COVID time, China built a hospital within a month, isn't it? So like that, there are quick constructions. So the scheduling will also affect the type of foundation, right? And you should cleverly choose the type of foundation depending on the factors, depending on the type of building, to avoid long duration being spent for construction of the foundation, and also the cost. Construction risk, right? Yeah, risk just now we saw sudden interruption of water, sudden landsliding, sudden rainfall. Everyday risk is the rainfall, right? They are doing concreting, there is a rainfall, that's finished, right? They cannot do, they have to stop the work, right? So there are risks encountered which has to be addressed properly. Coming to the important point, bearing capacity of soil, right? These are all general. I didn't go into shallow foundation yet. Bearing capacity. What is bearing capacity? It's defined as the maximum load per unit area. Pressure, simple word, pressure or stress. Stress, strength, all are measured by this unit, isn't it? Newtons over meter square, or pascals, right? We can call this as a pascal. 1 Newton over meter square is called 1 pascal. So bearing capacity of the soil is determined by load per unit area. How much load, overcoming load, it may be live load, dead load, wind load, which is transferred to how much cross-sectional area of the footing or foundation is called as bearing capacity, which the soil will resist safely without displacement, right? Avoid displacement, avoid skewing, avoid settlement, avoid breaking, right? Avoid dismantle, what do you call? spoiling the structure, right? Demolition. The bearing capacity of the soil can be found by locating the soil, noting the settlement, and by dividing the maximum load by the area on which the load is being applied. So simple word. Okay, I have also given the equation later on. The same equation will be used. How to calculate the bearing capacity? It's the ultimate bearing capacity of the soil over factor of safety. We have bearing capacity, but you should not be designing for bearing capacity of the soil. You should, you can determine by testing during the beginning of the site clearance, excavation, earthwork. We did take the samples, tested for its properties, tested for its bearing capacity, right? After that, you cannot be designing for that bearing capacity. You should go for safe bearing capacity. That means over factor of safety, some factor of safety. Say for example, 1 kilonewton per area meter square is the bearing capacity. You should go for 1.5. That's the value of safe bearing capacity. You design for 1.5. Make it as a higher value, which is which should be borne by the building or borne by the foundation. That's called factor of safety. In other words, factor of safety is equal to ultimate bearing capacity divided by safe bearing capacity. In both way we can say, or you increase some percentage of loading to be borne by the footing so that your design is safe. Okay, is the point clear? If the column, if the footing is supposed to bear 50 newtons, you increase by 50%, right? So design for 75 newtons, then you are safe. This is what I explained by this equation. You need to take safe bearing capacity of soil, which is 75 newtons when it is supposed to bear for 50 newton over meter square. On completion of a structure, there may be some displacement in the position of the foundation. So you need to check, because initially you do the foundation. As the building go on, there is a loading, right? Dead load keep on increasing. So at the end there is a chance for displacement. So in the final drawing, the completion drawing, you can show all these, and there are methods to overcome, methods to protect, methods to and solutions to do the fixing of this problem. And some of the solutions we can see at the end of the slide. Sizing of the footing. Okay, this loading is important to decide what is the size of the footing or what is the size of the foundation. I use the word footing and foundation reversibly or invariably I'm using it. The meaning of footing is there is a difference between footing and foundation. Okay, footing means normally the shallow foundation, we can use the word footing, right? It is not a real foundation. A footing or just a strip or a mat or a strap or raft can be a foundation, called as a foundation. These type of shallow foundations are called footing. We cannot use this footing for deep foundations, right? Deep foundations are real foundations. You have to use the word foundation. So this footing is very commonly used for shallow foundations. When I say footing, it's related to shallow foundation. The area of footing can be determined from actual external loads such that allowable soil pressure is not exceeded. Same, the area, once you know the loading, right? Once you know the loading, the area is given by area of, the total load that is coming in, the self weight, maybe including self weight, right? Total load including the live load, dead load, bin load if it is skyscraper, at all divided by allowable soil pressure or bearing capacity of the soil. This is known as bearing capacity of soil. Safe bearing capacity of soil, that just now we determined here. Safe bearing capacity of soil. Okay, the sizing of the footing in one line, we can say a simple equation, a thumb rule. A quick calculation can be obtained by dividing the total load divided by, dividing the total load by safe bearing capacity of the soil or allowable soil pressure, right? Artificial methods to improve bearing capacity of soil. Okay, you can also see some of the improvements for the foundation by increasing the depth of foundation, draining the subsoil water, pumping out, compacting the soil properly, confining the soil mass, cement grouting, injecting chemicals like silicates. Once you decided the type of foundation, right? or during the discussion, during planning for type of foundation, you can go for these improvement methods, earth improvement method or soil improvement methods, and then decide which type of foundation has to be designed, planned, constructed. That can save your time, money, and also the efficiency of improve the efficiency of the design. See here, by see that whether you can increase the depth, by that you can reduce the cost. Sorry, what do you call, increase the strength, right? See whether by increasing the depth can increase the bearing capacity. By draining subsoil water, right? If there is any subsoil water, find out the root cause, root, find out the pathway, the quantity that is flowing there. Avoid or draining out the soil water, subsoil water by proper compaction of soil. If you found very loose soil, all of you know that the subsurface soil is very loose. Most commonly, the subsoil is found to be loose. You can compact the subsoil so that it is hard. Very rare you can see subsoil is very hard, and you can go for shallow foundation immediately. Most of the places it will be shallow because there is a propagation of root, right? And the root will be ending at hot soil, right? That will be below the subsoil. Hence, you need to check whether by proper compaction you can do the soil improvement, earth improvement. Confining the soil mass, right? Confining the soil mass. Again, it is related to compacting and proper leveling and proper processing of the soil. You can treatment of the soil. You can have a proper by improving. The treatment should be directly proportional to increasing the mass of the soil. All of you know what is mass, right? Kilogram, the weight of the, the mass of the soil, the quantity of the soil. By cement grouting, right? There is a cement slurry. You can also use cement slurry mixed with soil so that the air spaces are packed, air spaces are filled, and you have a fine compaction. Injecting chemical like silicates, clay type silicates are more in clay and sandy soil. So you can also have a injection of this mixture of sand and silt, sand and clay, so that you can have a proper binding, proper compaction of the soil. These are the ways you can improve the bearing capacity of soil before you design this type of foundation. Essential requirement of a good foundation. Foundation should be so located that it's able to resist the unexpected future influence which may adversely affect its performance, right? You have to, there are some unforeseen things. Suddenly the wind, the climate changes, right? Become more windy. Suddenly it may be heavy downpour. I mean, that particular type building may be subjected to a 100-year return flood. I don't know whether you studied this thing. 100-year return flood, 1000-year return flood means a flood that will happen once in 100 years. The quantity, magnitude will be very high. It is not like your daily rain, which is 3 centimeter maximum, 5 or 10 centimeter per day. No, it will be huge, about a meter, like tsunami. Tsunami minimum is 10 meter high, isn't it? So this type of huge downpour will be there once in 100, once in 1000 years. So if the building is subjected to this type of return period floods, right, that is unforeseen, for example, I'm telling, your building should withstand. Further, you cannot be designing for 100-year flood because it's a residential building. By you have to encounter to some extent to avoid this unexpected failure due to unforeseen calamities. Then foundation should be stable or safe against any possible failures. So use the materials, proper methods to have a stable and safe foundation. Foundation should not settle or deflect to such an extent that will impair its usefulness. So should be stable, should be strong enough, should not tilt, should not get displaced, right? All these things should be avoided by proper selection of the type of foundation, material, manpower, and so on. There are many factors, but care should be taken for designing a good foundation and construction. While talking about the failures, major types of failures, let's see how they may be failing. Here you're seeing the type of failures, 3 types of failures. This is a building framework. You're seeing skeleton of the building, multi-story building. and this is the footing, and this is the column, first level, second level, this is ground level, right? You can see this is the small portion of the footing and the foundation here, and this one is the, maybe we can call this as a basement, and this is the footing, and this is a column, right? All this type. Here there is no settlement, right? The level of the ground and level of the footing all are unchanged. When you go to total settlement, whole building itself settled to this height, isn't it? There is a small height from the original level. Total building is settled, and there's a differential settlement. Each column or each row, there may be chances that this particular will be at some level, and this is very low, and this is not, or this is undisturbed. Maybe it is undisturbed, and this is again undisturbed to some distance below. So automatically you can see the sway here. The building is swayed, building gets deflected, the beams get deflected due to failure of the foundation or failure of the building itself. Any questions so far? Any question? Are you there? Hi, are you there? Okay. What is supposed to be done? Uniform settlement is usually of little consequence in a building. Can you see the slide?
Yes.
But differential settlement can cause severe structural damage, right? So uniform settlement, we can still handle it, but the differential settlement, like this is uniform settlement. Uniform settlement can be handled by proper projecting proper column and column pad. We can construct underneath the ground. You can lift the building together, but differential type very difficult and complex to design and protect against this type of failure. So care should be taken while choosing the foundation in the beginning itself. Distribution of soil pressure. Different types and how the soil pressure is being distributed in pictorial form. You can see here. I want to draw and show. Okay, I explained through this drawing. You are seeing here a column load which is resting on the footing, right? A shallow foundation, maybe a column pad or a mat, right? A square, rectangular. You are seeing the cross-sectional elevation. It can be a rectangular footing, right? A soil pressure distribution in non-cohesive soil, sandy soil, and cohesive soil, clay, right? Cohesive soil and non-cohesive soil. You see here the distribution. I'm sorry, you should remember those compression, tension type, right? If you understand that, you know, you can understand this part. Due to this, this type of foundation sitting on a sandy soil, you will get a extended failure, right? The forces are like this. The failure is puncture is more. The column is getting punctured, and the distribution of loading is towards the sides, isn't it? Towards the sides. The column will go deeper into this structure, deeper into the footing, causing expansion of the sides due to sandy soil. When you come to, and this type of failure is called common in non-cohesive soil, causing an extension or tension type. The force is tensile force. When you come to this part, due to this, what happened to the footing? The footing is bent like this. Means what? Extended, elongated. The force due to elongation due to the force is caused by tensile force. And coming to this one, soil pressure distribution in cohesive soil. Cohesive soil or clay type, for example, it will be caused like this. Due to the loading, the footing will get compressed towards the end. Okay, towards the end. Maybe over the distribution of this overcoming load is not uniform. It will cause a type of a compression. So the whole footing itself get cramped or get reduced in size like this, going inward. This type of failure is called, this is another type of failure. You should avoid both of them. This is tensile force, this is due to compression force. In general, we can call this as a shearing stress. We will discuss about shearing, puncture, shear stress later on. Why I call this as a shearing? Because one material is moving over another. During failure, one material column is moving over footing. We'll discuss in detail about this type of failures later with the diagram, but in general, either it may be buckled like this or it may be punctured, compressed like this type, due to tensile, due to compression force. Example picture you are seeing, soil type of shallow foundation you are seeing. See, there are nicely spaced. These are the columns. These are the finished footing of foundation. You are seeing the different columns spaced nicely, and this is about to construct, right? About to construct the column. This is the finished footing, right? Finished footing, isolated footing. You can call this as isolated footing, which is meant for constructing the columns above. Okay, is an example view of a building under construction for foundation, a shallow foundation. What is shallow foundation? Let's move on to detailed study on shallow foundation. Every engineering structure. Any questions so far?
Oh, miss. Oh, no.
No question.
Please remind me. Wait, I check the time. Time, right? Stop me at 6:20, and the quiz will be posted tonight so that you can finish and submit by tomorrow. Okay, I assign timing until tomorrow afternoon, say for example until 2:30. Hello. Okay.
So, miss, today there is no quiz on Kahoot.
Yeah, today there was a request. You have midterm exam today, right?
Yes. Yes, it's dynamics.
Yeah. Due to that, I'll leave you at 6:20 because I'm sure I cannot finish before 6:20 and conduct this quiz. But I assign the quiz to you by tonight around 8 o'clock. It will appear. You start doing your quiz yourself. Okay.
Now I have a question.
Yes.
When are we going to represent our project?
When?
The project, the one that we're preparing the other day. The presenting.
Team presentation is on week 12.
Team or individual? It was
individual. Okay, thanks for remaining. I saw the file. Only 108 people have submitted already. I left with 6 more people. Please fill up your title, which is found at file section. You need to complete. I'll prepare the schedule and send to you. Okay, it's at week 12. Like this, I will open the screen and invite one by one. Give permission to present. Others will be listening to them. Okay, just 3 minutes only. Share your experience.
Okay, ma'am. Thank you.
Yeah, welcome. Another few more minutes only. Don't worry, I will not extend much today, since you are all very busy with the exams. Okay, what is shallow foundation quickly? Every engineering structure, whether it is a building, bridge, highway, pavement, railway track, all structures on the ground should be supported by a foundation. Hence, it's important a prior structure, which is the master, or the parent for any building. The function of the foundation is to transmit the load from the superstructure to the soil stock. All studied already. How it should be for a shallow foundation? Shallow foundation, always the ratio is depth to breadth ratio will be less. In other words, breadth will be more than depth. Depth is very low compared to breadth. Then it is called shallow foundation. On the other hand, if the depth is very deep, very high than the breadth, then it is called deep foundation. Okay, bear in mind, depth to breadth should be less for shallow. Depth to breadth should be higher for deep foundation. In quick, if you want to select very quickly what is the type of foundation, the first and foremost thing you have to consider is by depth and breadth. If the depth of foundation required is less than the breadth of foundation, then you will go for shallow. If the depth is more, like some feet, hundreds, 50s, 20s, then you go for because shallow foundation hardly it can go up to 3 meters, 5 meters, maximum 5 meters, 3 to 5 meters, not more than that. If the hard soil is found nearer, like up to 3 meters, 5 meters, you can go for shallow foundation. 5 also very high, 3 meters I can say. 3 meter deep, you can go for shallow foundation. If more than 3 meters, then it is called deep foundation. That means what? The depth is determined by the type of soil, loose soil or hard soil. So the hard soil is not found until 3 meters below. You should go for deep foundation. A foundation, quick one, a foundation which transfers building load. A foundation which transfers building load to earth very near to the ground level compared to deep foundation. Yeah, very near. That is 1 to 3 meter. Can you imagine 1 to 3 meter? Height of a room, right? Maximum height of a room. Footing, I can call this as a footing, right? Below the base of the wall or column for a purpose of distributing the structure load over wide area. A footing is the kind of a base, a rectangular platform, rectangular base, a slab, which absorbs the load from the column or distributes the load to a wider area. It is having a wider area to bear the load that is coming over. The real difference between shallow and deep foundations based on structural response as well as the depth to which the foundation is taken, right? Just now I explained to you, depends on the depth, you can decide. If it is deeper, you must go for the deep foundation. Shallow, like up to 3 meter, you can go for 1 to 3 meter, you can go for shallow foundation. If the hard rock is found, hard soil is found up to 3 meter, you can go for shallow foundation. Bending is the predominant structural action in the case of shallow foundation. Yeah, you have to check whether there is a deflection, bending, right? Just now we saw two types, right? Tensile and compression type. If there is any, if you can check the soil for bending stress, and if it is predominant, you should go for, bending is predominant structural action in the case of shallow foundation, right? Because of the smaller depth you're going in, there are high chances of bending, of flexural, or you need to determine the flexural strength of the soil before you decide what is the type of foundation, whether that particular shallow type of foundation can withstand this flexural strength. Otherwise, advice for deep foundation. Behavior of, there are equipments, even in our lab we can see equipments used for triaxial tests. Maybe seniors know, or if you go for soil mechanics, foundation engineering, you will be using this. You will determine flexural strength of the soil. Triaxial testing machines are available. The behavior of deep foundations could result in an axial or lateral load, besides bending moments and torsional moments. Here, flexure is more important. In deep foundations, torsions, bending moments, axial and lateral loads are all governing the most, right? When you go for actual design, you will understand an application and designing of these types of loading. Deep foundation, soil interaction needs to be detailed analysis. There are software like SAFE. You type SAFE software. I think freewares available, demo versions available. There are softwares for designing foundation. Example SAFE, and all types of structural analysis software can be used for designing the foundation. Only thing you are doing the frame analysis as though it is, frame analysis underground, right? StatPro, Revit, all using the structure on ground. The same structure which is underground can be analyzed using these types of structural professional software. Types of shallow foundations. Okay, quick one, and this is most important for you. This is the scope of study for today. I may be asking question in your assignments and your what else? The quizzes all based on these types. All the types and their limitations. You should be able to classify, understand the purpose, limitations of each foundation. That's the main purpose of learning this chapter. Spread footing, strip footing. See the name itself you can understand. You relate the name and the meaning of the word. Spread, strip, combine, strap, mat or wrapped. Okay, these are the things. Actually, when we were studying, there are only 3 types. Now become more evaluation come out. We can use 5 types of footing, shallow footing: spread, strip, combine, strap, and mat or wrapped. Okay, so comparison is most important for your assessments. Spread or pad footing. How is it? You see the diagram here is very easily understood if you look at the picture. This is the column, okay. I beam, not beam column, I sectional column is there, and there is a pad, right, and there is a footing. There is a footing. For single load which are transmitted down a brick pier concrete column, the most common foundation is a square or rectangular. This is always a square or rectangular type with the thick of pad. A pad is used in order to, it's a cushion like or intermediate element which will transfer the load uniformly to the footing. In order to spread the load over the greater area, it is necessary either to make the pad thicker or use reinforced concrete. Mostly it is slab with the reinforced concrete. If load increases or bearing capacity of the ground is poor, a larger foundation pad will be required. Okay, so spread or pad footing will be most commonly used in isolated columns. Okay, excuse me, who changed the
محمد لنا ستوري خواتك. Hello, Miss.
who is doing? Don't share the slide. I'm sorry, don't share the slide. Okay, one moment. I repeat. Okay, can you see the slide? Can you all see the slide? Okay, sorry.
Yes.
Don't try to share the slide. I don't know what function I updated by MS Team. People are also can share the slides, but until you are permitted, don't do that. Okay, I will quickly go through these types of footing and the variations. Mostly for isolated columns, very spaced columns, right, where the building is sitting, you can go for these type of footings. Here you can see the column. I think we have finished all this already, right? Yeah. A larger area needs to be, this load needs to be transferred to a rectangular area. It may be circular, rectangular, or square, depending on the design. Okay. Spread footing types. Again, the further types of spread footing are here. 5 types are here. I read here. Stepped wall. It's all. See here. This footing. What may be the immediate structure over the footing? Anybody? Quickly. What may be the immediate structure above the footing or foundation? Possible structures. Come on, quick. Please answer. I repeat the question. What structure will be sitting on the foundation? Very first, the bottommost. What element of the building will be sitting on the footing or foundation? Column. Very good. Any other? You can be wrong. Don't worry, because I am teaching. Wall. Wall, right? Okay. Mainly it may be a wall load or column load. Okay. In most of the building, most of the design, you can see the column or wall will be sitting on the footing. Accordingly, the classification goes. Come on. See here. Stepped wall footing, sloped footing, single column footing, grillage column footing or foundation. Okay. See here the one by one. Sloped column. Okay, the column, this is the distribution is not directly to the square area or flat square area, but a sloped column, right? And then this one, a sloping is provided before it reaches the footing. And then simple wall footing. A wall is sitting on a footing. Simple column footing. A column is sitting on the footing. Stepped wall footing. Stepped wall footing. The wall is not directly transferred to the footing, but by a stepped distribution. A wall load is distributed to the first bigger size or broadened wall, and then to the footing. Okay, it is not directly transferred to the footing, but through a broadened wall or a pad, and then to the footing. stepped column. It is not directly to one or two layers, a few layers of few steps before it reaches the footing here, right? A column load is distributed after all steps of distribution finally to the footing at the bottom. Okay, it's called grillage and the special name is given grillage footing. There are very interesting videos I want to show, but I'm sure you are very busy with the preparation. Limit this by pictures only. But I posted the videos in the slides. At the end of the slide, you can find the website, useful website for more reading and understanding.
Teacher, where can we get the slides?
Yeah, I will post now. I mean, at the end of the class, I will post the slide.
Okay.
This is the, see here, rectangle, I mean square footing. A column is sitting on this. It's a constructed one, and then it's ongoing, right? The construction is ongoing, right? You see here, isolated footings, right? It can also be done by strip footing. Depends on the location and site condition. We will see one by one. Single footing, or isolated footing, or just a spread footing. Strip footing, where it is necessary. A wall footing, right? Mainly for sitting or loading a wall onto the footing. Directly loading a wall onto the footing, you will construct what is called a strip footing. A strip. The name itself, a strip. A pad, a long strip, a long basement, or a long construction, rectangular construction is done to support a wall. The serve spread the weight of the load bearing wall across an area of the soil, right? Load bearing walls, main walls are sit on the or transferred to the footing by what is called strip or wall footing. It's just a continuous, I mean, all along the wall. The footing is constructed all along the wall. It is unlike the last time. There are rectangular pads, right? Equally spaced, or there are some space between. There are some space between foundations, right? The footings. But here there is no space. A strip of wall, a strip of basement, or a strip of footing is constructed for a foot or 2 feet to hold the entire wall. Okay. Combination of spread and strip. See here, the spread is here, right? An isolator, a spread to hold the column is here, and this is for wall. Okay, strip, a strip or a straight or a stretch of can be called as a stretch. A stretch of footing is designed or constructed to hold the wall here and here to hold the column. It's a combination, combined spread and strip. Come on, what's the advantage? Combined footing is a single footing which supports 2 columns. When columns are very near to each other, and their footing can be overlapped. And center of gravity of the footing area should coincide with the center of gravity of the combined loads of the column. A combined footing may be rectangular or trapezoidal plan. When you go for combined footing, when the columns are closely spaced, okay, when the columns are closely spaced, necessary to, according to the design, the columns are closely spaced. You don't have to do the isolated one. You can do by this type of combined footing. Care should be taken. You see, this is very important point. What do you mean by center of gravity? Quick one. We don't have much time. What do you mean by center of gravity?
Point of equilibrium.
Okay, equilibrium. Okay. In other words, in technical terms, mechanics of materials terms. Equilibrium, yes, it's there all at equilibrium condition. Then you can solve. Any other word? Center of gravity quickly. There are 2 things you should know: centroid and center of gravity, right? There are differences between centroid and center of gravity. Let's understand what is center of gravity first. What is center of gravity? The point towards which all the forces or net forces are acting, isn't it? It's very interesting if you draw and show. Okay, let's see here. This is a square, right? This is a column. The distribution is, if you draw a perpendicular line on this, there are pressure acting at this point, this point, this point. You can put many arrows onto this block, isn't it? And the total force or the net force will be acting at the center of this column, right? the point towards which the net force is acting is called center of gravity, right? It should be uniformly distributed throughout the structure, then the structure is safe, right? And that's why the point is given here. The care should be taken such a way that in a combined footing, see you having a strip, right? The strip centroid should be chosen such a way that it is coinciding with the centroid of the two loads coming here. Okay, you can do analysis, you can do plot the bending moment and the forces coming on the structure, and then decide at what distance the central point is coinciding. Based on that, you can decide the length of the strip. I repeat once again, this is the block of the strip, right? To conduct for a combined footing, you have a isolated and also spread, and then the strip together, right? This being combined means two columns or adjacent columns are combined if they are closer in such a way that the center of gravity of this footing, okay, center of gravity of this footing will coincide with the net forces, right, or center of gravity of these two loads onto the structure. By that, you are safely located or safely constructed the combined footing. Your question, later we'll see with the diagram at the end. We'll see one type of failure. At that time, I'll show you the force diagram. Okay, so you need to design such a way that both coincide. Come on, centroid. I talk about centroid. What is centroid? What is centroid? Any idea? Is it different from center of gravity? Engineers should know this. Is it different from centroid? Center of gravity? Come on, answer me. Are you there?
Yes, different.
How? What do you mean by centroid? Can be wrong.
The center of the shape.
Very good. Geometry, center of the geometry of the element is called centroid. If it is square, you can see you just cross these diagonals. Midpoint is this one, right? And hexagon, join all the diagonal opposite sides. The midpoint is the centroid of that particular element. Geometric center of the element or any structure is called centroid. On the other hand, center of gravity is the point towards which the net force is acting, the total force is acting, or the section is weaker at that point. Okay, right. You need to design stronger by proper elements and thickness.
Teacher, it's almost 6:20.
Oh, you God, I have to finish. Okay, Les, thanks for reminding. 2 more minutes. Okay, 35. There are 20 more slides. We will continue in the next class. I will post the quiz by 8 p.m. right? Or I will post it now. You can start doing it. You can finish by tomorrow at 12 o'clock, mid of the day, right? 12 p.m. noon or 12 noon. You can finish and submit. I give you enough time.
Some have exam at 6:30. Can we leave?
The do it is only for this lesson.
Yeah, this lesson. Only for this lesson. I cover only these 35 slides.
And what about the attendance?
Attendance I have taken. I'm having attendance already. Don't worry. Nowadays I can download the attendance from the people section here. So don't worry about the attendance. Okay. MS Team has option to download attendance, people participating. So I'm doing since past 2 weeks. I started doing that way. Don't worry about the attendance. I have downloaded already the Excel sheet. If you want, I can post to you.
I have exam at 6:30.
Yeah, you can go. But I stop here for the class today. Thank you so much for listening. Please prepare well for all the quizzes. Bye-bye. See you next class.
Okay, thank you, teacher.
Miss the quiz you post on Microsoft Teams, right?
Yes, I post the link so that they can access.
Miss, can you please upload the slides on CM?
Okay, I do it.
Thank you.
Give me another half an hour. I post everything for you. Okay. Thank you. Bye-bye.